So this was the question that I was asked. It says there's a mixture of salicylic acid, which is a weak acid, and sodium hydroxide, which is a strong base, and mixed together to make a buffer. Select a mixture from the table that will produce the buffer solution. Give a reason for your choice. So the answer is Z, and I'll explain why it's Z in a minute. I'll just go through a tiny bit of theory first of all. So what is a buffer solution? Well, a buffer solution prevents changes in pH. It opposes changes in pH. You can add a little bit of acid or a little bit of base, and the pH doesn't change very much at all. So what you do is, sometimes they're called acidic buffers, you get a little bit of a weak acid, and you mix it with its salt. I'll explain what that means in a minute. So ethanoic acid is a weak acid. It dissociates in water, as all acids do, to make H+ ions, and it leaves something called an ethanoate ion, CH3COO- behind. That's a salt. So after the H+ has been released, it leaves ethanoate ions, or a salt. You can actually make, and you need, in a buffer solution, you need to add a little bit more of that salt. So that's what a buffer solution is. It's the weak acid making ethanoate ions, say for example, and hydrogen ions, and you've got to add a little bit more of that salt. So where do you get the ethanoate ion from? Well, you can get it from sodium ethanoate, which is the pure salt, and dissolve it in water, and it makes ethanoate ions. So you could do it that way by adding a little bit of sodium ethanoate. Or you can add sodium hydroxide, a little bit of sodium hydroxide to the mixture, and the sodium hydroxide reacts with a little bit of the ethanoic acid and makes sodium ethanoate in the mixture. So you've got to add a little bit more of that ethanoate ion. You can either add sodium ethanoate, which will do that, or you can add sodium hydroxide into the mixture, and the sodium hydroxide reacts with ethanoic acid and makes sodium ethanoate and water, and that makes the ethanoate ion for you. So in the buffer solution, I need a little bit more of the ethanoate ion. How does that work? How does a buffer solution work? Well, if you look at that first part of the mixture, ethanoic acid and ethanoate ion and hydrogen ions, and I've made a little bit more of the ethanoate ion in there to make sure I've got enough of that. Should I add an acid? If I add an acid, H+, and I've got some more of it on the right hand side because I've added a bit more H+, it can react with the ethanoate ions, and the equilibrium shifts to the left to remove the hydrogen ions, the acid that you've just added. And that's why I need a little bit more ethanoate ion to make sure that I've got enough ethanoate ions in the mixture. Should I add some more acid, H+ ions, that there's ethanoate ions in the mixture to be able to react with it and shift the position of equilibrium to the left and remove the H+. Should I add a little bit of base, OH-, well, that will react with the acid. So the acid, the ethanoic acid that's in there, will react with any base, OH-, and shift the position of equilibrium to the right and remove the OH-. So let's have a look at what the answer is then. The answer is Z, and the reason it's Z is because the sodium hydroxide, which is a strong base, reacts with the salicylic acid, the weak acid, to make a small amount of the salt. It's just like instead of ethanoic acid, I've got salicylic acid in there, and instead of ethanoate ions, I've got a different kind of salt. Doesn't matter what it is, sodium salicylate. Doesn't matter what kind of salt it is, but I've added sodium hydroxide to it to react with a little bit of the salicylic acid to make a little bit of the salt. And you're going to need a fewer amount of moles of the sodium hydroxide so that the salicylic acid is still in excess. You still want the acid in excess, the ethanoic acid still needs to be in excess, or the salicylic acid needs to be in excess. You don't want to neutralize the mixture by adding equal numbers of moles. And then what will happen is, I don't think this is part of the answer for the question, is that if you add a little bit of acid to the mixture, then the salt will react with it and shift the position of equilibrium to the left. Or if you add a little bit of base, say for example some kind of hydroxide, then the acid the salicylic acid will react with that and shift the position of equilibrium to the right. So in short, sodium hydroxide is added to make a little bit of salt for the buffer mixture, and you're going to need less number of moles of the sodium hydroxide than the salicylic acid, so that you don't neutralize all the salicylic acid and the salicylic acid is still in excess. The second part of the question then says another mixture was added. You've got 50 centimetre cubes of salicylic acid solution to 25 centimetre cubes of sodium hydroxide. Work out the pKa. Well, I've just picked this question up here from 2019, a paper that we did the other day. Let's just have a look at the shape of this curve. This is propanoic acid, a weak acid again, similar to salicylic acid, and sodium hydroxide, the same strong base. If you look at it, what am I doing? I've got the acid, the propanoic acid in this case, and I'm adding some sodium hydroxide in small amounts from a burette, probably, and measuring the pH with a pH meter. And the pH starts at 3, because propanoic acid is a weak acid, around about pH 3, let's say. And then the pH starts to go up. But what's actually happening is the sodium hydroxide is reacting with the propanoic acid and making a salt, probably in this case something like sodium propanoate. And when I've got the sodium hydroxide making the salt with the weak acid, I start to get a buffer. So that's at around about, when I've got around about 1 to 2 centimetre cubed of sodium hydroxide added in, I'm starting to make the salt. It's like, just like there, where I've got ethanoic acid and I'm adding sodium hydroxide to make some of the ethanoate ions. I've got exactly the same thing here, except I've got propanoic acid, so it wouldn't make ethanoate ions, it would make propanoate ions, but the same thing's happening. I'm adding a little bit of sodium hydroxide to it, and I'm starting to get that salt made, and I'm starting to get buffering made at that point there. And at that point there, the pH stops going up. It flattens off, because that's what a buffer does. It resists changes in pH. Now, what's the actual question asking on this one then? It's something called half equivalence point. If you see pKa, what happens is, when I get an equivalence point, that's when there's equal number of moles of acid and base added, or you could say when the line goes up quickly in terms of pH, I've got equal numbers of moles added. So you find about the halfway point or somewhere on that steep line going up, and you measure down. And you see how much sodium hydroxide needs to be added to neutralize the acid. And in this case, I'm reading down, I think it's around about 19.5. Then what you do, you half that. If you half it, you don't really need to know the whole theory. So if you half that, half of 19.5 is 9.75. And you find the pH at 9.75. And at that pH, when you've added half of the sodium hydroxide needed to neutralize the acid, then pH equals something called pKa. So 4.9 equals the pKa. If you're asked then to work out Ka, as you were in 2019, then 4.9 is pKa's minus log of Ka. That's what the pH means. It means minus log, as in pH minus log of H plus concentration. So pKa is minus log of Ka. And then you can do minus 4.9 is log of Ka, log to the minus 1 of minus 4.9, or inverse log it, and the Ka is 1.26 times 10 to the minus 5. Let's have a quick look at this one then. What would you measure? Well, you'd measure the pH. And if you actually look and calculate the salicylic acid, the number of moles is 0.05. The number of moles of sodium hydroxide is 0.025. Well, you've got half the number of moles of sodium hydroxide as salicylic acid, so if you measure the pH at that point, then pH is going to be equal to pKa. So you've got to show for the explanation half the number of moles of sodium hydroxide as there are salicylic acid, maybe by doing a little calculation or something like that, and then explain that half equivalence point, when half the amount of sodium hydroxide is needed to neutralize the acid, then pH equals pKa.